May adlaw class. This will be a recorded lecture for the sample problems na aton kailangan nato i-tackle after sa lesson 3 sa DC machines. So before we proceed sa sample problems, let's have a quick run through sa mga important na mga formula. First is ang equation sa EMF or ang E sub A. So sa E sub A or ang EMF equation na atay mga variables and ang ato ang EMF equation is directly proportional sa P, phi ug N as well as Z and inversely proportional sa alpha. So ang atong EMF is directly proportional sa number of poles which is ang P. Then we also have ang phi or ang flux per pole or simply flux. Then ang N is ang speed of rotation nato in terms of RPM. Ang phi is in terms of Weber. Tapos ang Z is the number of active conductors or simply number of conductors sa ato ang DC machines. Then we have alpha which is the number of parallel paths kung asa nakabutang ang ato ang mga conductors or ang number of slots nato. Then we also have an alternative version sa ato ang EMF equation which is EA is equal to K sub A phi omega M. So ang phi is ang flux per pole. Then we have omega M which is speed in terms of angular velocity. So we have 2 pi over 60 multiplied sa tong N or sa tong speed. Then we also have Ka or design constant of the machine. And Ka is equal to Pz divided by 2 pi alpha. So mapansin ninyo class na kaning kani siya is mostly about kaning Ka is about kanang fixture sa ato ang machine. So helpful ni siya sa part na kanang sa fact na ang ato ang DC machine can be used both as a generator and a motor. So ang Ka is the parameter that doesn't change on both situations. So manang important siya na ma-learn nato. Then we also have the torque equation for our DC machine. So ang atong torque is simply ang pwersa sa rotation sa atong DC machine. So most often than not, mas helpful ni siya sa motor, sa DC motors. So we still have Ka. As I said, dili na siya mabago whether you use the DC machine as a generator or a motor. Then we also have the flux per pole and this time nagdungag taog Ia which is the armature current or current flowing throughout the armature. Then we also have equations for the equivalent circuit sa aton DC machines. So dari na mo pasok tong concept sa terminal voltage o back EMF. But first, ang field voltage nato is simply the product of IF or ang field current nato for self-excited DC machines. Multiply that with the equivalent resistance atong field kay coil man gyapon na ang ato ang field na kana bitang field poles. Coiled gyapon na siya, so electromagnet gyapon in principle. So na siya equivalent nga resistance which is R sub F. So man siya tong field voltage. Pero mas helpful sa tong problem solving is ang armature terminal voltage or VT. So VT is equal to E sub A or katong EMF. Balik ta dere. So natay EMF equation E sub A. So lahi pa jud ang VT or ang terminal voltage. EA plus or minus IARA. So ang Ang kalahian ani nila class between a generator and a motor is that ang plus sign will be for motors, then ang negative sign will be for generators. So, naka-explain dari that for a motor, the terminal voltage is always greater than the generated EMF or ang back EMF na itong natakel sa previous na itong lessons. And the electromagnetic torque produces rotation against the load. So, medyo mo oppose siya against the load. Mo nang dapat ang terminal voltage is always greater than the generated EMF or back EMF in the case of motors. Now, for a generator, the terminal voltage is always less than the generated EMF, and the electromagnetic torque opposes that applied to the shaft by the prime mover. So that's the difference na for a generator, mas dako gyapon ang EA na ma-generate kaysa sa terminal voltage. It is because mo deduct diha ang IARA nga voltage drop. So this is a voltage drop for generators. So important na class na ma-learn na to once na mag-design ta og DC machines na dapat ibutang dyan na to sa tong design na mas dako ang generated EMF or E sub A kaysa sa terminal voltage or VT. Then we also have field and armature currents. So magsugod ta with self-excited series. Dili ni siya kanang separately excited dapat ni siya. Adi lagi. Self-excited ni siya puros kaso lahi-lahi siya ang the aspect nga natay shunt, natay series generator. So sa series generator, equal man jud ang current sa to ang series generator mo nang naatay equation na equal lang ang atong armature current ug atong field current from the line current or ang overall current na naga-flow sa atong DC machine. But for a shunt generator, ang armature current is equal to line current plus or minus ang field current. So kani pud siya magdependa po ni siya whether ang atong machine is used as a generator or used as a motor. So for a generator mo gamit ang plus sign, it is because mudagdag sa ato ang armature current ang ato ang field current. So makita nato na dito sa atong previous lesson ko i-review to ninyo nga mag-abot ang line og ang field current sa atong armature current. Pero mo-deduct na siya kung gamiton nato ang atong machine as a motor. So important na siya nga matun-an nato pag abot nato sa atong problem solving. Then we also have the speed equation. So ang speed equation nato dari is in terms of omega m or ang angular velocity from which ma-obtain gyapon nato ang n or ang speed of rotation sa atong DC machine. So kani siya nga equation class, this is assumed as a motor. So ngano as a motor man? It is because of the negative sign. So pang motor na siya. So VT minus IA RA over KA phi or ang flux per pole. So man na siyang kanang murag quick na equation para kuha na to ang speed sa ato ang DC machine. Now let's go to the sample problems. So first dari is kani a 4-pole DC machine with 782 active conductors and 30 milliwebers flux per pole runs at 1,800 revolutions per minute or RPM. First line dari, if the armature winding is lap wound, find the voltage induced in the armature given that the number of parallel paths is equal to the number of poles for lap windings. So, ako na siyang gi-copy dere. So, magsulat ta og solution. So, if the armature winding daw is lap wound, meaning na nga to ang number of parallel paths in a lap wound armature is equal to the number of poles. So, gipangita ang induced EMF or E sub A. So, E sub A, gikan sa dari nga formula, kani. So, we have times Z over alpha. And that's equal to, ang number of poles na to is 4. Then, ang flux per pole na to is 30 milliwebers or 30 times 10 to the negative 3. Then, ang revolutions per minute na to is 1,800 divided by 60 times number of conductors is 728 divided by number of parallel paths, which is equal to the number of poles, 4. So, itong E sub A class is equal to 655.2 volts. So, ano siya itong final answer for letter A. Then, for letter B is same na conditions, but this time, the armature is wave wound. So, naka-specify dere na for wave windings, ang number of parallel path is equal to 2. So, nalang tayo duha ka buok nga parallel paths nga fixed for wave windings. So, let's check kung pila ang iyang induced EMF. So, same formula. We have number of poles 4, then 30 milliwebers, then 1,800 RPM, then number of conductors is still 728 divided by 60 times number of parallel path, which is 2. So, itong E sub A then is equal to 1,310.4 volts. So, in comparison, times 2 ang voltage na ma-produce na to with wave winding compared sa lap winding. Now, let's move to letter C. If the lap wound armature is designed to carry a maximum line current of 100 amperes, compute the maximum electromagnetic power and torque developed by the machine. So, ang una nato i-solve is ang torque, then ang electromagnetic power. So, ang torque equation nato is mao ni siya. TE is equal to KA flux, then IA equal to PZ over 2 pi theta phi times IA. So, i-substitute lang nato. Ang alpha nato is 4, kay lap wound man ni siya, times 30 times 10 to the negative 3. Then, nato ang armature current, maximum is 100 amperes. So, atong torque is equal to 347.6 Newton meter. So, basta torque gani class, ang ato ang unit na SI is Newton meter. Then, ang ato ang power or electromagnetic power is equal to voltage times current. So, mo na siya ang ato ang formula for power. But for the case of a DC machine, we have the induced EMF E sub A times ang armature current I sub A. So we have to use ato ang E sub A from letter A, which is 655.2 volts times ang armature current of 100 amperes. We have 65,520 watts or 65.52 kilowatts. So, mo na siya nga to ang power in terms of watts. So, mo na siya for number 1. Then, move ta with number 2. A 4-pole lap wound armature, so same sila to number 1. This time, it has 144 slots with 2 coil slides per slot, each coil having 2 turns. If the flux per pole is 20 milliwebers and the armature rotates at 720 revolutions per minute, calculate the induced voltage given that the number of parallel paths is equal to the number of poles for lap windings. So, ang wala na specify sa kaning problem class is ang number of conductors. So, mo na siya ang gidetalye aning 144 slots with 2 coil slides per slot, each coil having 2 turns. So, balik ta dari. So, E sub A gapon ang atong pangitaon. So, we have number of poles, 4. Then, ang flux per pole na to is 20 milliwebers. Then, we have 720 revolutions per minute. Then, we have ang number of conductors na to is now 144 slots times 2 coils slides per slot times 2 turns. So, ipang multiply lang diyan nato na siya class. Divided by 60 times number of parallel path is 4. So, that's equal to 138.24 volts. So, mo na siya to ang final answer. Then, move ta with number 3. So, natay 6 ka problems karon. Number 3, we have a 4-pole DC generator is lap wound with 326 armature conductors. It runs at 650 RPM on full load with an induced voltage of 252 volts. So, medyo physical ni siya ng mga characteristics sa ato ang DC generator. If the bore of the machine is 42 cm in diameter, its axial length is 28 cm, and each pole subtends an angle of 60 degrees. Determine the air gap flux density. So, still, ang number of parallel path for lap winding is equal to number of poles. So, wala ta naka-encounter so far og ingon ani nga problem class. Yes, kay wala man ni siya sa libro. So, mag-introduce na lang ta og kanang formula. So, Ang una natong buhaton ani kani nga problem is pangitao nato ang flux per pole. So pangitaan nato na siya gikan ani nga formula. So magre-arrange lang ta gamay. So ito ang induced voltage is 252 volts. Parallel path is 4. Number of poles 4. Speed is 650 RPM. Then we have 326 conductors. So ang ato ang flux per pole is 71.35 times 10 to negative 3 or 71.35 milliwebers. So nanatay flux. Then ang letter B na to is kailangan na to pangitao ng area sa ilalom sa pole. So we have area of the pole face, which is equal to 2 pi RL. So mana diha mo sulod ang katong physical characteristics like 42 cm in diameter, 28 cm axial length, and 60 degrees nga kanang distansya sa matag pole. So since given man ang angle sa pole, so isulat lang nato. Since each pole an angle of 60 degrees, so 360 degrees divided by 60 degrees is equal to 6. So meaning na natay 6 ka kanang pole faces, which is in contrary sa to ang 4-pole DC generator. So ngano dili sila match? It is because probably in this type of DC machine nagamit ta og kanang murag dummy poles or kanang interpole or commutating pole or compole, which is mahimong topic sa ato ang next lesson or probably a next recording. So dito na to na ma-introduce na siya na concept. But for now, let's proceed sa ato ang problem solving. So we have area per pole is equal to 2 pi RL divided by 6. So you have 2 pi. Ang radius is diameter divided by 2. So we have to make this a unit of measure in meters. So we have 42 divided by 2 is we have 0.21 meters. Then ang atong length is 0.28 meters. All of that divided by 6. So atong area per pole is equal to 0.0616 meter squared. Then finally, wala dito dapat nag-lettering dari. Maabot na ta sa air gap flux density. Or letter B na to. So ang formula ani, B is equal to flux divided by area kay density man. So substitute lang na to, 71.35 times 10 to the negative 3 webers divided by ang area of 0.0616 meter squared. So ang final answer nato diha is 1.16 T or toroids. Muna siya ang atong unit of measure sa air gap flux density. Now let's move sa ato ang fourth na sample problem. So a DC shunt machine, so wala gi-specify kung generator or motor siya, has an armature winding resistance of 0.12 ohms and a shunt field winding resistance of 50 ohms. The machine may be run on 250 volt mains as either generator or a motor. So find the ratio of the speed of the generator to the speed of the motor when the total line current is 80 ampere in both cases. So ang gipangita lang nato dari is ang ratio of speed kung generator siya og motor. So ang atong gamiton ani nga formula class is kanilang kaning VT or terminal voltage. Since as a generator or motor ay kanang kuan di ang EA di ay ang induced EMF is equal lang man siya for both cases. So we have EA for generator and EA for motor. So man siyang ratio na to ang gamiton. Or we use VT plus IARA divided by VT minus IARA. Then we have 250 minus 80 amperes. Tas ang armature resistance nato is 0.12 divided by 250 may plus din sa taas. Na ay mali class. So ang ato ang field current og armature current kay kailangan pa din nato pangitaan gikan sa line current. So mag-solve sa ta dere. Pananglitan i-solve nato ang IF which is equal to VF over RF. So that's equal to 250 divided by ang winding resistance is 50. So you have 5 amperes. So atong armature current karon is line current minus field current, or 80 minus 5. Atong IA karon is 75 amperes. So muna siyang gamiton dare, 75 times ato ang armature resistance, which is 0.12, the same pod sa baba. So ang answer ani is 1.074. So muna siya ang ratio. .074 is to 1. So mas dako ang ratio sa speed sa generator. Then move ta with, so let's skip number 5 for now. Let's go with problem number 6. So a DC machine operating as a generator develops 400 volts at its armature terminals, corresponding to a field current of 4 amperes. When the rotor is driven at 1,200 RPM and the armature current is 0. So first problem, if the machine produces 20 kilowatts of electromagnetic power, find the corresponding armature current and the electromagnetic torque produced. So ito is number 6. So to solve for this class, ang letter A is actually sayon ra kay na siya. Balik tayo dito sa power formula. P is equal to EA IA. So we have 20 kilowatts, so 20,000 watts is equal to EA, which is according sa problem 400 volts times IA. So ang atong IA or armature current in this case is equal to 50 amperes. Now, second problem, if the same machine is operated as a motor supplied from a 400 volts DC supply, so muna siya nga to ang terminal voltage, 400 volts, and if the motor is delivering 30 horsepower to the mechanical load, determine 1. The current taken from the supply, 2. The speed of the motor, and 3. The electromagnetic torque if the field current is maintained at 4 amperes. So muna siya nga itong IF. Assume that the armature circuit resistance and the mechanical losses are negligible. So, una na itong buhaton for letter B is to convert ang 30 horsepower. So 1 horsepower is equal to 746 watts. Or atong 30 horsepower is equal to 22,380 watts. So muna siya nga to ang power. So muna siya ang power na gina-deliver sa atong motor in this case. So ang atong VT or terminal voltage, isolve na to, gikan diha ang ato ang EA. VT is equal to EA plus IA RA for a motor. So since armature circuit resistance is negligible, so let's assume na wala na siya naga-exist. So therefore, ma-zero na siya, then atong VT is equal to EA or equal to 400 volts. So mana siya nga to ang voltage. So to solve for the armature current, IA is equal to P over EA. So gigamit na nato ang same formula. We have 22,380 divided by 400 volts is equal to 56 amperes. So mana na siya nga to ang answer sa atong armature current. Then number 2, we have to solve for the we have to solve for the torque first. So isolve na to si number 3 dere. So ang atong torque gamit ta ani nga formula. Kani. So TE is equal to KA theta IA. But also kaning KA nato is makuha po nato na siya gikan sa ato ang EMF equation. Which is kani equal di ay siya to sa atong VT. So balik ta sa number 2. Pasensya. So we have KA theta is equal to VT over omega G. So ma-solve na to ang KA theta first kay constant man na siya constant na siya sa to ang machine mismo. So we have 400 divided by 20 times 1,200 over 60. So that is equal to 3.183. So wala lang tayo unit na ibutang for now. Then isolve na nato ang angular velocity sa motor. So VT is equal to KA theta, which is equal to 400 divided by 3.183. So you have 125.67. So from there, ma-solve na po nato ang speed. Kay ano man na siya, equal to 2 pi n over 60. Yep. So n is equal to 125.67 times 60 divided by 2 pi. So 125.67 times 60 divided by 2 pi. So that's equal to 1,200 RPM. So man na siya ang atong speed. Then from there, ma-solve na po nato dayon ang torque. So gamito nato same nga parameter. So we have atong KA theta is equal to 3.183 times ang atong armature current, which is 56. So atong torque is equal to 178 Newton meters So mo na siya ato ang answer class. So if you have any questions regarding sa ato ang solve problems, you can leave it sa ato ang group chat. Thank you so much.